Yeah, James Harden here. Today we're solving LeetCode 19. Move inf node from the end of the list. This is more of a follow-up video to my last video because to show off a more efficient solution. The last video was a 2-pass solution. I'm going to show you a 1-pass, so O of n time and O of 1 space. Given to have a linked list, remove the inf node from the end of the list and return its head. So here we can see that n is 2, and we want the second node from the end. So the first node from the end would be 5. The second node from the end would be 4. As you see in example output, 4 has been removed. So for this example, I'm have a sample linked list here, and let's say n was 2. The fourth node here is marked with a green dot because that's the node. All right, so for this solution, we're going to use a fast. So I'm going to have f for fast and s for slow pointer. In the beginning, we're going to have fast iterate up the linked list n times. So let's say fast starts off here, and it's going to go n times. So it's 2. So 1, 2. So fast would end right here. Erase this. Next, we want slow to start at the beginning, and we're going to have both of them traverse up the linked list simultaneously, going up one position at a time until fast is at the end of the linked list. So fast is gonna move up 1, 2, so it's gonna be here, and slow is gonna mirror those moves, and it's gonna move up twice. So 1, 2, slow is here. And then once we get here, what we're going to do is say slow dot next, which is a 4 currently, is going to equal slow dot next. So it would be, so the sample output would be 1, 2, 3. And then we're going to say, so slow dot next, that pointer is going to point to slow dot next. So 2 spaces ahead. And slow dot next is 4, and that dot next is 5. So it's going to go straight to 5. And as you can see, it's a very, very elegant solution. I enjoyed learning this one a lot because it's quite efficient, but it's not very intuitive. So that's why I showed you guys the more intuitive but less efficient version of this video. There's one thing to be wary of in this solution is that there is a bit of an edge case. Let's say, for example, n was the length of your linked list. So let's say a 5. So let's say if we tried that again, it would say fast will move up 5 times. So 1, 2, 3, 4, 5. Fast would be at null. Slow would be here, and we can't move them up simultaneously because there's no dot next on fast. On null because fast is at null. So what we do is say if fast equals null after moving n times, we're just going to return head dot next because that means that we're removing the first node from the linked list. That makes sense. Because the only way that fast would ever equal null after moving n spaces if n is the length of the linked list. So if n is 5, then we just want to return head dot next. So that would just be everything from the 2 forward. There we go. So hopefully that made sense, and I'm going to show you guys the solution here. So first we're going to initialize fast, so let f equal head. Fast, let me zoom in a bit for you guys. Let slow equal head as well. And we're going to say have a for loop. So we're going to say for let I equal 0 while I is less than n because we're moving n times. Then we do I plus plus. And we want to say f fast equals fast dot next. Therefore, we're moving up n times. So we've done that. So in this example, we've moved up n times. But let's say that fast is at null. Let's say n was 5 and it's at null. That means we know we want to remove the first node in the linked list. So that means we're going to just return head dot next. So we're going to say if fast, well, we could say if not fast, turn head dot next because we want to remove head dot next. And then here we're going to say if we never hit this condition, then we just want to move slow up until fast is at the last node. So we're going to say while f dot next is still valid. So we're going to go all the way up until we're at the last node, because here's when fast dot next is null, and that's no longer valid. So that's when we're going to stop. We're going to say f equals fast dot next, and slow equals slow dot next. Now everything is in position, and we're just going to say slow dot next equals slow dot next dot next. There we go, and just return head. And if we get this first try, I'll be ecstatic, but knowing my luck, I don't know. Judging. Oh, and look at that. We solved it first try. So this is a very fast solution. It beats 100% on runtime and 50% on memory, or 72% on memory, so it's quite efficient. So I hope you guys liked the video. Enjoy. Peace.